Hello, everyone, and welcome to IO Extended UK and Ireland. Today we have on stream presenting Sharon, Dr. Nabil, and myself, David Renton. So, this is our third or fourth time on stream together. Sharon, how's things going with you?
Great. How's all with you, Div?
Really looking forward to moving back into in-person events. I really miss it. Nabil, man, you must be chomping at the bit to get back to in-person. The amount of training you're
Abs- Absolutely, my friend. Absolutely. Yeah, we stuck with this. Everything is online, so looking forward to getting back to some normality, seeing some faces, meeting, having some drinks with some people. Really.
absolutely love it. Come here, I'm just going to move these slides along and take care of some business. We've got a few announcements to make until we move into our first presentation. So we are the Google Developers Groups. Now, this is the one we want. Now, let's see if this works better.
Area.
There you go. It's working.
Got it.
Champion, look at that. Live on stream and everything.
What I'm most proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDJ, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of the community members a lot. So I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Hey, I managed to get it fixed. Look at that. That's brilliant stuff. So as we saw, there's a lot of developers, a lot of people get inspired by turning up at events and just finding something or somebody they're interested in, end up with a mentorship, end up just creating stuff or really enjoying themselves. There's some great stories around the community that I'm sure Nabil you see over in England, Sharon you see in the Midlands in Ireland, and me in the west of Ireland. And we're not full-time people. This is something we do out of love. Like Sharon today has an appointment later on, but still wanted to be a part of the event. She's going to be with us for the first hour, and then she's got to head off. And then it's just the two beautiful people left, myself and Nabil. You know, that's it exactly. We could tell you multiple stories about different people that have been involved and turned up at events a year or 2 years later, like we saw in that short video, with stories of their own to tell. Are people that have become leads in their own communities after attending some events. So it's a global community. It's for everyone that's interested in tech, or even interested in just coming along to hear about what's going on. I mean, some of our speakers later on will impress upon you the amount of effort they've put in because they love it, not just because they have to or it's a job. It's a real love. So Google Developers Groups is a developer community program supported by Google and Google developers. It is for us, the people. So today we have IO Extended. I really should have done more presentation practice on these slides before we started, but we're here now. IO Extended events are organized by Google Developers Groups all across the world. They happen after IO and generally talk about the topics that have been announced on the live stage at Google I/O over in San Francisco. During this presentation, it will be 17 Google Developers Groups. We all communicate on and contribute to events happening in the UK and Ireland, as we're in lockdown and we can't do in-person events at the moment. So we have 17 Google Developers Groups, 1 student club and 1 SRE group. And we are lucky enough to have one of the leaders of that SRE group speaking this evening. there are multiple tracks. There's 3 on tonight, 3 on tomorrow night, and 3 on Thursday night. So if you can tune in, pick up some new information, watch some experts talking, or like we like to have in the Google developers groups, someone do something cool and present it and go, hey, this is something I did. This is something cool I did. I'm just going to show you guys. They don't have to be an expert. You just have to want to create and want to share it. So you are watching the cloud track tonight. If you had intended to be somewhere else, you can change the streams from our YouTube channel. And we'll just take care of some housekeeping. So the general rules are, watch your comments. Please be awesome to one another. Very simple rules. That's about it. Is that it, Sharon? Have I covered everything?
That's it. We have the code of conduct, I think, coming up next. That goes a little bit more into the rules, but yeah, basically be nice.
No, we don't. Haha.
It's done.
So that slide must have been taken. I think the rules are enough. Just be awesome to one another. We're all here for the same reason. So, Sharon, G2G Athlone, how's things going there?
Things are great. We love being part of the wider community. So meeting every week with everybody. The group's actually gotten a little bit bigger, the leads in the group. So Dave, as an ex-Athlone G2G lead, you'd know, but we have a couple of newer people coming on and becoming leads and trying to get things sorted and organized. And here we are today.
Absolutely love it. Great job. Nabil, how's things going over in Leeds?
Yeah, awesome. Yeah, brilliant. I mean, we're getting used to the new normal. So this collaboration between the GDG groups made a big difference. So we're basically having to attend all the events that happens, all the groups. So it makes a huge impact on the community. So yeah, brilliant.
It really is, and to be honest, being in the west of Ireland, it's nice to get expertise like yourself, Dr. Nabil, to be able to be on stream with us, and we can promote this from our own section of the world, and have experts like we have joining us today, Rich Rose and Joy Campbell, and we have a surprise 2 guests at the end that are they're first timers, and we love this in GDG. I mean, that's the best thing ever when someone's willing to go, hey, we did this cool thing and we're going to share it. That's like the best ever, and I think
Absolutely.
It should inspire more people.
Absolutely.
So, yeah, Nabil, you got some Twitter followers down there. If anybody wants to tweet about jellyfish training, I know they're active. Genesis security stuff. Anybody want to? No, we won't. Okay, but we are hiring. Yeah. Genesis are hiring. Just to say that, pay the bills, guys. So we do have a code of conduct. We have it up online at devparty.io. Code of conduct. I suppose that thinking about it now, Sharon, is exactly where I would expect to find it. It's amazing that. Put things where you expect to find them.
Exactly.
So our agenda tonight is we're going to start off at 6:15. So you're stuck with me, Sharon, and Nabil for the next 6 minutes, and after that, we're going to hand off to Mr. Richard Rose of Google. He's going to do a talk on the facets of bringing various languages to developer workshops and the languages we choose. Following that will be Sharon introducing
Joy Campbell and getting the most out of cloud and adopting patterns.
And after that, Dr. Nabil will be introducing our
Kiki Lago and Rob Eves. They'll be talking about payments in the cloud from 3 months to 3 minutes. Really exciting talks. We're looking forward to those guys as well.
Yeah, it's going to be great. So we're going to try and hold our questions to the end so we can stay in sync with the other tracks that are rolling at the time, just to allow people to jump between tracks if they find something interesting. So while we do really enjoy your questions, and speakers have all FYI, I muted you guys. Yeah,
sorry, I muted you guys while the video was playing. Realized I put it in the wrong chat.
It's okay. Don't worry about that. So it's up on the chat for the stream. You didn't mute us, guys. We're not muted anymore. I got awful confused there for a second. I don't know how to get rid of that now either. It'll have to stay there until we figure it out. All right. So we'll have a wrap up questions and answers at 7:45. If our speakers can hang around, they will. As I said before, we're going to be missing Sharon as she has a previous engagement, but we're lucky enough to have her for the first little while. So I will see if our first speaker is ready, and we will give him the full half an hour that he has to present, if that's okay with everyone. Yeah,
let's go.
Everyone.
Bring on Rich.
Mr. Rich Rose, Hello, sir.
Oh,
it is.
hello.
I know you weren't listening at all, were you? Okay, so be social, be share. We have our hashtag here, Google I/O extended UKI. You can post about the event. Please do so. Share the love. Tell people about us. We want to share it with as many people as possible. Our first speaker, as you have seen, I've ruined the surprise, is Rich Rose. So if any of you don't know who Rich is, he is the author of this book right here, and he should be telling more people about it. And I seem to, every time whenever we go on stream together, have to say this, that he is an excellent author and has written a book on serverless computing with Google Cloud, and it's brilliant.
Well, thank
Buy
you.
it, steal it, do anything you can to get a hold of it. Well, no, he's listening.
he's also-
Don't steal it.
Yeah, he's also a trainer on Coursera. A brilliant security course in there. So yeah.
Oh yeah.
Yeah, absolutely. Learned a lot from Rich. Yeah, hey, stranger.
And he's also a massive Metallica fan, so you know.
I know, actually. How do you know that?
Very humble is Rich. Very humble.
Wow,
we should have started with that he's a massive Metallica fan.
Yeah.
And then the rest is inconsequential. Apart from
See, Rich, we know a lot. We know a lot about you that you don't know that we know.
Okay. That's good. Well, I feel honoured. Thank you very much. It's
a privilege to have you, my friend.
Awesome company. I guess it's me now. So should I be sharing my screen?
Well, I will stop sharing, and then you can have at it. And once you're good and comfortable, we'll duck out and leave you to present, sir.
Let me present this. Share. Okay.
I bet you're really looking forward to in-person events as well, Rich.
It's going to be good to get back to normal, I guess. Hopefully, if that's the situation. Woohoo! Okay, first time, but not that one. I want this one instead. So stop that one. I want this one. You know when you have too many screens.
Oh yeah, sure, for sure. I made a mess of the video we were playing earlier. I forgot to share sound, so I had to stop in the middle of the stream and go, which tab am I supposed to be sharing? And looking through the whole thing's going, please don't be anything that's work related. Please don't be. So, if you need to change tabs while you're working away, Rich, I'll be watching and listening, so I'll be adding in and out of the stream for you. And if I'm not, you can shout at me, and I'll be right here for you, buddy. Okay.
Sure. Nice one.
Okay. Well, it is 1:45. We will duck out and let your good self educate us.
Okay. Thanks very much.
See you later, Rich.
Bye. Okay, I believe I am live, so let me just start at the beginning. So about me, my name is Rich Rose. I am a lab architect at Google Cloud. I work in the Cloud Learning Services organization, which is responsible for a number of things in terms of content for Google Cloud. We also do certification. We do lots of the training events. So if you've been to Next, Google Next, then we're involved in that. Outside of work, I do other things. So I also write a lot. So my blog at the bottom of that contains many of my thoughts as I've gone through different iterations of code over the years. Also, as previously mentioned, I am author of Hands-on Serverless with GCP. I'm also the presenter for the security specialization. So if anybody's got the professional cloud security engineer, got that out, then you've probably seen me if you've watched either the Coursera or Pluralsight video. Okay, that's enough PR. Okay, so the next thing is what is this talk about? So this talk came about because of, for the longest time, I wanted to introduce development labs into the hands-on space. So when you're doing online training, typically in the cloud space, it will be around infrastructure, so using infrastructure in different scenarios and basically aggregating infrastructure with software. And while that's all very interesting, ultimately, you'll often get to a point where you would like maybe 20% of your resource to do something quite specific to your use case. And in that instance, what you're looking at is the development piece of basically building on top of existing infrastructure or software, or perhaps both. So in general, this can be seen as super, super complicated. And sometimes it is. However, what you can do is, with probably minimal of effort, is to get to a point where you can understand how the lab environment can be built. And by a lab environment is basically any environment that you have. So whether that's on your local machine, on your laptop, or based in the cloud. It's really about understanding the fundamentals of how that's all put together. And typically that will be, you've got an underlying platform, so your operating system, you've got some infrastructure on top of that, and then you've got some nice software, and that's the bit you can play with. If you're working in an online environment, such as Quick Labs, you might have some thresholds there in place because obviously the cloud is not free. So this talk is really about that situation and relating it to the work that I do on a day-to-day basis, and some of the issues that I came across and how I resolved those issues. Okay. So fundamentally, when you are creating a new environment, you essentially go through a similar kind of life cycle to the one that's on screen. So at the beginning, you will try to create some form of startup mechanism. And that can be, actually, I need to create something like a virtual machine. And then on top of that virtual machine, I may need to install something like a web server. And that startup gives you the foundations for your actual environment that you're building. So once you have that virtual machine and that web server available to you, you can then go on to build brilliant stuff. So maybe have a nice API on your web server or serve some other type of content. And that's great. But what does that actually mean in terms of you using that? Because ultimately, anything that you do, you want to be repeatable in terms of the resource that you spin up. You want to be able to give that to someone else so that they can repeat it. So a lot of the time, if you're like me, when you go onto the internet and you follow various tutorials, you might be frustrated by the fact that actually I can't replicate what this tutorial is actually providing for me. So if you follow any of the cloud-based tutorials in terms of software or infrastructure, oftentimes you'll find that they miss out a key piece that of information that is not available to you. Whether that's, oh, you need to set up billing. This resource is only available if you have some form of high reputation account. You need a specific type of GPU associated with it, etc., etc. So this provisioning life cycle is really talking about, well, how do I get to a point where I can, A, provision my environment successfully, but B, make it be in a position where I can pass that on to someone else and they can replicate that. And in my day job, this is part and parcel of what I think about every single day. So how do I get to that nirvana, that perfect position of having something that people globally can spin up, use, and then end in a successful manner? So if you think about if someone is trying to learn something like Cloud Run, for example, that lab associated with Cloud Run needs to run in many geographies. It needs to run on different operating systems. It needs to be compatible with different browsers, etc., etc. It's a complicated process. So where we get to with that is that we want to make that compatible, sustainable, and repeatable across a number of platforms. So how do we do that? So we do that in a number of ways. We do that by looking at the maintenance piece. So the maintenance piece is super, super important. So whenever you're looking at either infrastructure or software, you really want to be looking at, well, how is this resource used? So if I'm implementing something like a web server, I want to know what that revision of that web server is. I want to know how well it's supported. I want to know what kind of licensing mechanism it has. So all of those pieces together give me an indication as to whether this piece of software is something that would be useful in terms of the things that I want to use it for, or maybe it's going to be something that's going to provide me with a headache because the support isn't there, the licensing is restrictive, it has a number of issues that have been raised in terms of the actual software revision, and I need to go to another revision to get past all of that. So oftentimes it's good to do a bit of homework upfront in terms of what you're actually going to use in your project. And that goes for infrastructure and for software as well. In fact, I often think of infrastructure and software in the same way. So from an infrastructure perspective, if you are intending to use a particular product, such as a virtual machine, maybe move to the Kubernetes platform, maybe go serverless, it's really trying to understand how that mechanism is portrayed, how that lifecycle exists, and how you can best utilize that in terms of your own particular situation. So in terms of that, let's have an actual example. So one of the things that we come across on a day-to-day basis is a breakage in terms of labs. And the breakage of labs is typically signaled by either an end user or via an internal process where the CI/CD process breaks down in terms of the revision could be incorrect, the resource could be incorrectly configured, the version might have been updated. There are a number of reasons. And when that occurs, someone, it could be me, has to come in and fix that. And the starting point for that can vary. Now, one of the things that you probably want to do in terms of that situation is have a well-established practice about as to how that works. So in this diagram, we have a practice of having a startup routine. That startup routine begins by provisioning the infrastructure. It then goes on to provision the software layer. And then only once the two tiers have been completed and signaled successfully, it then begins the startup routine for the lab. Now, in terms of this helps the team to resolve issues that relate not to the lab, but to the startup process. And we treat the startup process separately. So what this means in an overall detail is basically what we're trying to do is break down the components that are used in terms of the startup and the lab specifically. Now, the provisioning of the infrastructure becomes a particular component, the provisioning of the software becomes a particular component, and then the lab separately becomes a particular component. And that means that anyone coming into this process can quickly and easily look at the element that is affected by the defect. And that also makes it much easier to resolve in terms of the infrastructure and the software layer. Okay. So how do we practically do this? So in terms of general process, we've learned a lot of lessons from general DevOps. So one of the things that we previously did was all of our code was held in version control. However, what we've learned is that actually it's not necessarily just the lab contents, the lab manual that needs to be held in version control. In addition to that, what we should also be holding in version control is things like the infrastructure as code. And that allows us to change that infrastructure independently of the lab. And it also allows us to be in a position where any software that's provisioned as part of that infrastructure can also be changed independently. From that, we are now in a position where rather than having to treat any lab as a monolith, we can actually delve into the various components and treat them individually. And that means, as a bonus, we can test each of those components individually, which is an absolute lifesaver, especially when you're running a global training organization where the breakage of a lab is a major event. Okay, so we have all of that, but what does it look like in practice? So if you consider the situation of the installation of something relatively straightforward like a Kubernetes cluster, a Kubernetes cluster will typically have the infrastructure piece. So the cluster, including the nodes, deployed relatively straightforward. What you might find is that you'll need to deploy some form of workload on top of that cluster. And to do that, you'll need some form of controlled software. So whether you go for something simplistic like a bash script, or whether you go for something more sophisticated down the line, it's completely up to you. The point is, from that you typically want to be able to reach a point where you split out the various components. So on the left-hand side, the way that a typical GKE cluster might be deployed is that you'll have some form of script from your infrastructure as code going out into your cloud environment. And from there, it's going to work out actually what nodes need to be deployed. And then on top of that, create all of the resources necessary. So the emphasis of the left-hand side diagram is actually, in terms of that approach, a better approach is to split out the various tasks and activities associated with that resource provisioning step. And by doing that, what you get to is the situation on the right-hand side. So on the right-hand side, you still have that same infrastructure as code, provisioning all of the resources. But now, as you implement each of those resources, you can actually check as a signal to see that initially that node and that cluster has been deployed correctly. And you can tick the box to make sure that that has worked before moving on to the next step of perhaps introducing some service accounts, which will manage that cluster and getting a tick in that box again. And then for the final piece of the puzzle, if you have something like a service mesh being deployed, so here we've got Istio, again, that is not deployed until we see completion signals for both the cluster, which is the underlying infrastructure. We see the service accounts, which is required to administer the cluster. And then finally, the software tier, which is the service mesh being installed on the cluster with the established service accounts. So here we're seeing that we can address a nice pattern in terms of being able to simplify the actual process of sending out information, but we can also make sure that for each stage of that provisioning step, we can get the relative signals back to indicate to us, yes, this is working as expected, and then progress to the next step. And this is very similar to how you might approach a development task. So having that initial function or method to run a particular piece of code, and then having a test to verify that that works. So it makes it much cleaner and much more maintainable going forward. Okay. So where can I see the results? So the results of this are in many places. So this is effectively like a seamless rollout of the back-end infrastructure and software that you might see in terms of if you're a Quick Labs platform user. Many of the labs that use things like Kubernetes will have this type of deployment strategy put in place. However, the thing that we use it for across the newer labs are things like development labs. So development labs are ones that include languages such as Go, Python, JavaScript. More recently, we've done labs in terms of Flutter and Dart development. And one of the reasons that has been useful, highly useful for us, in fact, is it has enabled us to roll out hotfixes quite easily across a global distributed platform. So previously, if a lab went down, we'd have to investigate that in isolation and then effectively try to fix that. So you'd see that horrible, this lab is offline notification. Whereas now what we can do is actually isolate that back-end piece and see that information presented in the back-end system, which is isolated from the students in the front end, test that in isolation. And then once it's passed all of our tests, we can roll that out and update the lab. That update is seamless to the front end, which is basically everyone who's using it across the globe. So how do we use this? So one of the ways we use this is in labs such as this. Now I'm going to have to switch, I believe, to a new window. So I need to share. So I stop that and share this and find the right tab, which is going to be you. Okay. So one of the newer types of lab that takes advantage of this new build process is where we run code servers in the cloud. So this is a new type of lab that has only been enabled probably in the last, I want to say 3 or 4 months, I think. So they're still relatively new. We're still beta testing them, but the intention is to have multiple types of language development environments set up so that students can go onto the platform and learn different languages. So this particular environment has been set up for Flutter and Dart development. And if anybody's ever done Flutter or Dart or Android development, you'll know what an incredible pain it is to set up the whole environment and the editor, etc. So this basically gives you that whole environment ready to rock. So all of the SDK is there, all of the updates are there, etc., etc. So when it comes around to a new version of Dart being released in terms of the SDK or the framework for Flutter being updated, that's all run in the background. The labs that you see before you stay exactly the same until the point where we need to do the update. So in this instance, we're running Code Server version 3.10. There's a new version of Code Server being made available, I believe, last week, which is 3.11. So what we do in terms of the update to this, previously we'd have to effectively rebuild the entire lab. What we do now is we basically go to our Git server, we update the code which builds this to say we want to use version 3.11. We commit that code. Once the code has been committed, it then goes off to Cloud Build. Cloud Build will say, I have a new commit, and therefore I need to build a new version of the compute image for this lab. And it goes off, does all of the fancy stuff, builds it, and then hey presto, we have an approval waiting for us to basically see if we want to sign off on the new image. Once we sign off, that new image is then enabled for all of the labs across the globe. And whenever you reinitiate this lab, so run it again, your lab will take advantage of the new image. So it makes the whole process a lot more seamless and a lot easier for the content development team, in addition to the students using the various labs. Okay. So if I just switch back to this, and then I want to share this one instead. Okay. So that was a brief look at how we do various development labs and the infrastructure and software provisioning behind it. Ultimately, the thing that we're seeing most is that we're using a lot more CI/CD practices. We're using a lot more DevOps practices as well, which is good to see. But the fundamental thing that has helped us throughout this process is to effectively use Git as a single source of truth, not only for the lab content, but also for the infrastructure and software that is deployed in each of the labs as well. So hopefully we'll be able to roll this out to more of the labs and take advantage of it. But that's effectively where we are at the moment, and that's the presentation. So any questions?
That was a great presentation, Rich. Thanks very much. You mentioned a bit about the infrastructure as code. Are you willing to announce to the world and our watchers what you're using? No. Am I? Oh, okay.
So we use a couple of things. So at the back end of the majority of the labs, we have a combination of deployment manager specific to Google Cloud. We also use Terraform as well. For the Kubernetes stuff, we're starting to see a requirement to use, is that released yet? Well, I don't know whether it's released yet, so I won't mention its name, but we're starting to see the use of other stuff, which is coming to the market soon.
That close to getting exclusive. Well, next, let me just share screen if that's all right, because I know we're going to try to hold the questions to later to keep in sync with the rest of the tracks. We have Mr. Jai Campbell coming up next. We still have 5 minutes before the end of your scheduled talk. Maybe we could get Jai in together, because I've been threatening since before the pandemic to get the two of you guys on a road show together, and it just hasn't happened yet. So I don't know if you've actually met each other yet. Jai, this is Rich.
I think only virtually.
Just virtually, yeah.
Yeah.
Pleased to meet you, Rich, and virtually again.
Virtually again.
Yeah, but I'm so up for a road tour. So yeah, let's do that.
I'm telling you, you heard it here first, guys. Road trip. Jai Campbell and Rich Rose. The SRE
cannot wait.
Super Security Show.
Let's do that tomorrow.
Let's do it. Let's just get it done tomorrow. Just wish this COVID thing would go away. Well, I hope you're all well and vaccinated, and everybody that belongs to you is healthy. Rich, I don't know if you can hang on until the very end for questions, if any comeback or a bit of a conversation.
Yeah, I'll try. Yeah.
Okay, in which case I shall let Sharon introduce Jai Campbell. Rich, feel free to stay in, or you can duck out. It's up to yourself.
Yeah, so I think you've been fairly introduced now with Jai Campbell, and we're going to have a lovely talk on getting the most out of the cloud and adopting patterns. So I suppose Dave, myself and yourself do like to try and get little googly facts out of people. So Jai, do you have something unique you want to let the audience know that is not related to your talk about you?
Unique. Wow.
Quirky, something quirky.
Don't be shy, or else I'll jump in there. You know, I've got the goods, Jai. Come on.
I'm learning to speak Japanese at the moment, so that's something pretty new for me. A bit quirky out there.
That is. So we're going to see you talk in the future in Japanese.
Ideally, yeah. Watch this space. Give me a couple of months, and then we'll get it together.
Hold on. I'm just going to say something. If anybody here has ever received a personal email from Jai, his signature section looks like a 3-star general, with all his accomplishments and certifications across the bottom. Which means he's got nothing to say.
You've just given me an idea there, David. I could get them made physically and have them on my shirt. Would be pretty cool.
I think you should. If I had that in any Jai, I would have done that immediately, if not sooner.
Put that on my to-do list.
And this is what happens when people come together and talk. Ideas are born.
Yeah, I'm gonna rock that for GCP next. I think. Watch this space, David.
Absolutely. Well, listen, Jai, we'll let you take it away. Everybody's excited to hear what you got to say, so we'll just we'll wait for you to share a screen, and then we'll duck out.
Thank you. Let me just share my screen. I think we're ready. Great. Can you see?
We are up and live. Now, sir, we're going to duck out. We'll be still listening. If you need us, friend, you can just shout.
Fantastic. Thank you.
Best of luck.
Best of luck.
Great. Thanks. Okay. So thank you, everybody, for joining us today. Thank you for taking the time out of your busy schedule to join us at Higher Extended. I'm really happy that you could join us, and grateful that you come to see my talk. Okay. I may be a little bit nervous at the beginning. I've had some terrible internet connection today, so my camera might cut out, but let's get quickly ahead with the show. Getting the most out of cloud adoption and adoption patterns. So, a quick introduction about myself. My name is Jai Campbell. I'm a software engineer, senior architect at Wipro. I form part of an ideas team which specializes in helping organizations, large and small, move their services, new and existing, into cloud services. I specifically work on the team that handles GCP, but I've also worked on other engagements with other platforms such as Azure. Outside of GCP, I love cloud native. I enjoy gaming, outdoor sports, traveling, spending time with my daughter, and I actually have a little tool here for my talk tomorrow. I love spending time on AR and VR devices. Google Daydream, very cheap, very fun. I suggest that you have a look at one of these, or come to my talk tomorrow and find out about the game that I'm building with this device. I run an SRE community, so let's kind of switch over to that tab here. Oh, actually, GDD groups. I'm not part of GDG officially. I'm an SRE community, but we work collaboratively with GDG. And as such, GDD do events like this, virtual and in person. The community that I represent specifically is London SRE. It's a free community. You can find us on meetup.com. This is our mission statement. Site reliability engineering is a way of life. As cloud evolves, so must our approach to operating such platforms. The aim of the group is to collaborate on projects such as these. We do a lot of meetups, and at the moment it's been mainly virtual, but hopefully it's going to be back to being in person. The group is open for all, and if you'd like to join, the link is on the bottom there. One quick point, Nisha is the co-organizer with myself, and we've been running this group for 14 months. Yeah, it's a really exciting group, and we do events similar to these. Here's a couple of pictures of the London SRE community. There's Nisha giving a talk. We have guest speakers. That's Jennifer Stretchwich. She's a contributor for CNCF for the instrumentation specialization, I think. And there I am giving a talk. This was a really cool session that we had. It was a cloud study jam. We had attendance of about 30 engineers for 3 hours. It was in an investment bank. As you can see, we was using their data center. And kind of similar to this talk, they was going through a digital transformation where they was moving from on-prem into GCP, and they were standing up their own SRE team. So we was giving a discussion about how to build your SRE functions internally. Okay, so today's discussions: cloud adoption, FinOps, SRE, and then a quick recap at the end. I'm cautious of time, so it'll be a whirlwind tour of each, and then we can answer any questions that you may have at the end. So let's kick off with the first, cloud adoption. So, digital transformations. I'm not sure if you know this quote from Gladys Knight. It's a really cool song, The Way We Were, but everybody's talking about the good old days, right? Everybody, the good old days, the good old days. Well, let's talk about the good old days. Digital transformations are all talking about taking what we want new and then reinventing that for the future. And the same with Gladys Knight and the music that she produced in 1974, that would have come out on 12-inch records. And then due nature of time, it's made its way onto CDs. And that shows you how the music industry has had to adapt in terms of it was physical and now it's virtual. They've had to move into the cloud and have live services, and music essentially is MP3 and it's all virtual. So times have changed. Digital transformations are what lots of industries are going through now, and it will happen in the future. A quick shout out to Pip, Python manager, dependency manager, really cool. I had to mention that because of Pips. Kind of a little geeky joke thrown in there. Okay, so if we're talking about digital transformations, quickly point out about the Cloud Digital Leader. It's a new exam and certification pathway from Google Cloud. It's job agnostic, and it's a really good starting place for somebody or an organization that's new to cloud, and even seasoned veterans that have been using cloud for many years, because this exam will assess your knowledge in 3 main areas. It's a good recap and a good refresher to get you up to speed on your general cloud knowledge, your general Google Cloud knowledge, especially if you're going to be working on this platform in particular, and then the variety and range of Google Cloud services, how you would use them. And I guess the main point of this exam and what it's trying to teach you is, if you have legacy applications or an old organization that maybe has been around for like 100 years or longer than that, there's going to be things you're going to need to change and embrace when you're moving to the cloud. And I think this exam does a really good job of addressing those points. At the bottom here, you'll see from Antonio Tavares, his review on the Cloud Beta exam. There's a lot of content to go through, but I do recommend that you have a look at that link. I followed that when I was going through the exam, and it really did give me a lot of information. Okay, so let's move on. Digital transformations. What are they about? It's about cloud adoption. It's about discovering what your organization is, what it's doing on premise, what it's already doing in the cloud. And it's about assessing the journey that you're on. You might have a 3-year plan, you might have a 5-year plan, and it's about looking at 3 main areas: technology, people, process, how they all come together in an organization. And if it's yourself working on a project by yourself, it's being prepared and getting ready for new members possibly joining your team or project and embracing and being able to scale. So let's move to the next slide. As part of this journey, there's 4 main epics that you would like, that you kind of recommended to follow to kind of help you on your journey. The first one is about learning. So the quality and scale of the learning programs you have in place to upskill your technical teams and your ability to augment your IT staff with experienced partners. So what does this really mean? Who is engaged? How widespread is that engagement? How concerted is the effort, and how effective are the results? Whether you're a large organization or a small organization, if you're going to make the journey into cloud and you're going to move existing systems that serve customers, there's probably going to be a requirement for you to upskill staff or bring in expertise from consultancy companies to get you in a position where you can actually manage the workloads and the cloud by yourselves. To have this, you need to upskill your engineers. And for this to happen, there has to be a lot of engagement throughout the organization. It has to be a top-down approach, because a lot of people's time is going to be affected, because to learn new skills, it's either going to be studying on your own time or on your company's time. So there's a trade-off. And again, you need that senior leadership team to make that effective. Okay, let's have a look at epic number 2. So lead, kind of building on the learning framework, the extent to which IT teams are supported by a mandate from leadership to migrate to cloud, and the degree to which the teams themselves are cross-functional, collaborative, and self-motivated. So again, leadership, top-down, but it doesn't end there. It has to be top-down, but everybody has to be involved. So this takes the form in terms of questions like, how are the teams structured? Is there lots of silos within the organization? Is there communication? Is there Slack channels, communication channels within the organization? Are meeting rooms set up in such a way that people can actually talk? Is there breakout sessions where people from different parts of the organization or company can come together and talk about ideas? Is there executive sponsorship? Again, is there budgets for people to learn? Is there a training budget for people to self-study? Do you get 20% time to actually focus on learning these new skills? And how are cloud projects budget governed and assessed? There needs to be some kind of way that you can validate that you're getting some results from all this effort that you're putting in. So how are you going to assess these? And we're going to answer some of these questions as we move through the presentation. Okay, so scale. This is more of the engineering side, but again, it's all encompassing, because once you start to scale, it's going to impact every part of the business. And this is the extent to which you use cloud native services that reduce operational overhead and automate manual process and policies. Again, we have a few more questions. How are your cloud-based resources and services provisioned? How is the capacity for workloads allocated? And how are the application updates managed? If you look at the diagram to the right, you can see a typical GitOps kind of process with deployments. You've got a source repo, and build and test, artifact storage, deploy and run. When you've got infrastructure such as this running on a pipeline, there's going to be several teams that are going to be working to ensure that every stage of this is working operationally, and it's working efficiently, it's reliable. And to actually manage this infrastructure, there's going to be engineering costs, there's going to be time costs, and there's going to be a skill requirement. And to bring this all together, you need a plan. And planning early is the best way to do this. I have a link at the bottom here for DevOps Performance. It's got some really cool information for you to follow up on if you're interested in terms of the deployment side of scaling when you move into the cloud. And then lastly, but not lastly surely, security. So the capability to protect your services from unauthorized and inappropriate access with a multi-layered identity-centric security model, dependent also on the advanced maturity of the other 3 themes. So again, we're wrapping everything up into a complete package. When you're building services in the public cloud, private cloud, on-prem or at home, you need to secure them from unwanted users. So what controls are in place? What technologies are used? And what strategies govern the whole? This has to be all-encompassing, because it's not just going to impact the DevOps engineers or the application engineers, users that work outside of traditional IT, such as those that might work in marketing or finance or payroll. They're going to be connecting with cloud services to secure the whole organization. Is going to be a whole group effort. And if we look at that larger here, if we're looking at cloud adoption and best practices, the way that you would envisage your company and your actual project yourself to move is to be a beyond core kind of authentication model, where you're building upon layers, you're taking advantage of cloud services that you're not relying on traditional security methods such as firewalls. You're taking advantage of advanced VPC controls and so forth. This is more for a mature company, I would say, but the earlier you can invest in these technologies and start to look at a beyond corp solution is going to save you money in the long run. Okay, so let's have a look at the cloud maturity scale in a little bit more detail. So overall, we're going to approach this in 3 kind of areas. There's going to be a tactical, a strategic, and a transformational. If we look at the top line first in terms of the technical maturity, we go back to learn, where it's being self-taught, third-party reliance. And then if we go, so self-taught and third-party reliance is where you've got your staff teaching themselves, and you're bringing in third-party contractors or consultancies or educational companies to teach your engineers how to do the things that they're going to be self-reliant on in the future. Moving across, we have lead. So teams by function, and we have a heroic project manager that's probably doing a lot more than they employed to do, and probably working a lot longer hours than they expected to do to get the actual project off the ground. Scale, so change is slow and risky, ops heavy. It's a lot of manual work, lots of scripting, not very many templates, and generally there's a lot of CAD meetings before things can go live into production. And then on the security side, there's a fear of the public internet, but trust in the private network. So traditionally you'd find historical companies or quite older companies will have on-prem or data center environments, and they're very reluctant to move into public or private cloud because there's not a lot of trust, and they've got security that they've been building for years and years, and it works for them, and they've got patterns that they already understand and use. On the strategic side, we're starting to move away from being reliant on third parties. We've got organized training with third party assisting, getting probation for our internal teams to start training themselves and training younger and newer engineers into what the actual organization is doing in the cloud. On the lead side, we have new cross-functional cloud team. So think of like a CCOE team, where they're governing and mandating everything that's going in the cloud environment. They're helping to orchestrate what's happening around, rather than just having one individual doing a lot of the work. On the scale side, we have templates now. So rather than manual work, we'll have blueprints, we'll have governance. There's rarely any manual intervention. We'll have pipelines producing the workloads, and generally we'll have runbooks and a much more organized infrastructure, and we'll be treating the environment as infrastructure as code. On the security side, we'll see central identity in a hybrid network. So now we started to extend our on-premises services into the cloud. We've got hybrid connectivity, changes are faster, we've built up the trust, but we probably still don't have our most vital systems running in the cloud. They'll probably still be running on-prem. And then at the end, this is the holy grail, you would say. We have the transformational side. So we've been through all the hard work. We're still working hard, but at this stage on the learn, we're peer learning. Third-party staff augments what we're doing internally. So they might teach us new skills on new products, and then internally we'll have the foundations to teach our teams how to do that ourselves. Cross-functional feature teams with greater autonomy. So think about having like SRE teams or FinOps teams that are really working hard and investing in the organization and providing the extra value. On the scale side, we have all changes constant, low risk, and quickly fixed. So we've got infrastructure as code, quick deployments, rollbacks. We're really utilizing the cloud in the way that it's supposed to be. And then on the security side, we have trust only the right people, devices, and services. And that kind of goes back to Beyond Corp. We've extended into the cloud. We're allowing our users to log in from anywhere in the world because we trust the connection and the identity that we're giving them in our services. So hopefully that gives you a little bit of an understanding about the cloud maturity scale. The adoption framework is a great white paper. I think it's 60 pages long, and it will flush out a lot of these concepts in a lot more detail. And again, we have a quick look here. We have tactical, strategic, and transformational. Tactical, short-term wins. Strategic, they're broader visions. And then transformational, that's where we're thinking 10x. We're building our own tools and instrumentation within the environment to suit our needs. And then if we look at the chart on the right, you kind of see how these all fit together. In the middle, there's a lot of overlap, but you can see if you're going to start to work on any of these processes, the key ones are the ones that are colored here. And these will, by virtue of fulfilling and working on such things as sponsorship and data management, upskilling, infrastructure as code, these will fill out, and everything else will kind of fall into place with instrumentation, resource management will start to form part of the process as your teams get more experienced of working in the cloud. Okay, so FinOps, where are we with time? 12 minutes, let's go. Quick run of FinOps. For those that are new to FinOps, FinOps is the practice of bringing together finance, tech, business, unit economics. It's accountability and enablement in the cloud. It's measurement and realization. It's cost optimization, planning and forecasting, tools and accelerators. In a nutshell, it's having a look at cloud spend differently from CapEx, where it's capital expenditure. At the beginning of the year, you're spending 10,000 or 10 million on a set of virtual machines in a data center or on-prem, to allowing individuals to kick off a virtual machine, which could cost you 10 million in one day. So there's a different mindset that you're trying to bring through to the organization. And then similarly to DevOps and SRE, there's a life cycle involved. There's a feedback loop. So first you'll start with inform. You have a look at your environment, you get visibility and allocation, you start to label things, you know where things are being spent. And then once you've done that, you get to the optimize stage, where you're starting looking at your rates that you're paying, maybe for VMs, maybe your discount usage. And then you go to the operate phase, where you're continuous improving on what you've been doing in the previous two stages. And it's a continuous feedback loop where every week or every month, you're looking at what you're spending, how you're operating in the cloud, you make changes, you review your bill, and then you rinse and repeat. It's essentially that feedback loop. Very similar to DevOps and SRE in that respect. Quick point here, this isn't any plug from CNCF. I'm actually studying for this myself, so FinOps for engineering. I've set the FinOps certified practitioner, which is really good. However, I think CNCF have recognized that there's a different kind of focus on FinOps, which is more specific for engineers. There's a self-paced course, which is paid, but there's a free course that you can find on the link on this slide here, on the edX course, which will give you a really good foundational grounding of what you need to understand for FinOps. And if you enjoy it, it's the start of your journey to look through that. Quick shout out to Quick Labs. Again, discussing cloud costs on GCP. You can often find free Quick Labs to take part in. And there's some specific ones around understanding your Google Cloud costs and optimizing Google Cloud costs. There's no better way than hands-on in terms of understanding how to work with the billing tools within the platform. And I would definitely advise using this if you have the opportunity to do so. Laying the foundations. So essentially, if you're building things in the cloud, whether it's a website, whether it's gaming, whether it's any kind of environment, there's going to be a few things that you need to kind of consider. There's principles and processes. So again, taking what we've just been discussing above and wrapping that around once you're starting to build your resources environments in the cloud. Generally, if you build anything in the cloud, you're going to need 3 main services. You're going to need compute to actually drive the computation and do run the applications that you're actually building. You're going to need storage. You're going to store the actual data that you're actually producing. And then you're going to have networking to connect your applications to your customers or to your users. With all 3 of these core services and core resources, there's some important tips that you should take into consideration before or after using these in the cloud. We start with optimizing compute costs. Only pay for compute that you need. Right-size VMs, purchase commitments, automate cost optimizations, and use preemptible VMs. And then there's auto scaling. I'm cautious of time, so I might skip through these a bit quickly. But what you can have a look at in terms of the native offerings is the pricing calculator. And then there's external tools such as websites, which can give you an indication of the latency from different regions for your VMs. And then when you're engineering your solution, depending on where your customers are, you can place those machines in a different region and work out which is the best cost for yourself. And then again, you can also use preemptible VMs. There'll be engineering. I guess the main point in terms of all of these slides moving forward, especially for optimizing compute costs, it's very easily just to use the default settings. But if you want to use the cloud in an intelligent way and get the most bang for your buck, that's when you have to start engineering around cost. Similarly, storage costs, clean the storage before you move to cloud. Data retention, think about the kind of data that you're saving, for how long, where you're saving it, the kind of access patterns in terms of who's accessing your data, who are the heavy talkers in terms of disks, and then performance considerations. Again, you can use the pricing calculator, and then there's flowcharts that you can also use that can allow you to make informed decisions about which is going to be the best storage solution for your needs, because you might be able to find a cheaper storage solution by using a database rather than the storage bucket. And then networking costs. Understanding traffic flows, identifying your top talkers, deciding when to use a VPN. Again, ingress and egress traffic out of the public cloud is going to be quite expensive at times. So working out which way to get your services to be reachable is going to be vital in terms of reducing your costs. And then looking at your logs is going to be quite vital as well to make these kind of determinations. Have a look at a network service decision tree to find out which networking solutions is going to be the right fit for your use case is another key tip that I would generally advise you to use. Okay, so 6 minutes left. We'll quickly go over SRE and how this fits together in the whole presentation and what I'm trying to get across here. So what is site reliability engineering? For any of you that are new and new to SRE, it's about ensuring the reliability of a system. It's about observability, ensuring that if somebody goes to your service, such as Google or YouTube or Netflix, as soon as they hit that website or application, the service is there and it is how they expect it to be. It's not an innovation team. They have a specific job function. They have their own boards and they have their own commitments within the organization. They're not there to fix everything. So it's good to make sure that everybody's on the same page about that. They measure everything, and root cause analysis is a big part of what SRE is about. They run postmortems and understand why things fail and then fix it so it doesn't fail again, or indeed it won't fail in the same way again, which is really important. This graphic here gives you a quick indication about what site reliability is and where it fits in the organization. Observability and monitoring are the foundations that support the entire platform. So SRE sits here right at the foundation. It's monitoring everything that's happening above, all the applications, the networking, any changes that are made to the environment. Generally, your SREs will be involved in creating the instrumentation to feed back to the teams. So if you look at that on a broader scale, SRE sits everywhere. And then I'll quickly run through this. This is the types of SRE implementations. So again, if you're wishing to spin up an SRE or a FinOps team where they both are going to work very closely together, there's no one size fits all. So you have the kitchen sink, aka everything SRE. It's the first SRE team in existence. And it's generally how Google started with theirs. You have an infrastructure team, which is a bit more easier to do the behind the scenes and then make other teams' jobs faster. You have the tools team, more of a specialist teams that are focused on building software to help their developer counterparts. And then number 4, we have a product/application SRE team, which works to improve the reliability of a critical application or business area. And you can already see that some of these SRE teams will fit larger organizations and some can work in any size. Then we have embedded. These SRE teams are embedded with the developer counterparts. I've been part of the embedded SRE team for some time, and it's one of the SRE teams I enjoy. I've also been in a consulting SRE team. The difference between these two is that consulting SRE teams tend to avoid changing customer code and are more on a read-only type advisory role rather than actually embedded and actually making changes on the actual customer's code base. I'll quickly jump back. The reason why I'm mentioning SRE with FinOps is because the SRE is creating the instrumentation, they're creating the logs, they're the ones that'll be able to inform the SRE team and yourself in terms of what you're spending. And if there's any anomalies on your platform where you can save money or reduce costs, that's the team that's going to be able to help you and provide you the metrics and insights. And then on the subject of moving to cloud, there's the Cloud Foundation Toolkit. If you're moving to cloud and you would like blueprints and you'd like a real quick and easy way to see how an enterprise would jump into GCP, these foundation toolkits are the best way and a real quick win. Treat your infrastructure like software. You can use this for FinOps and your SRE functions. You've got pre-built templates, and it allows you to maintain consistency across the whole stack. And then recap for the last 2 minutes. We're doing really good on time, which is fantastic. So the summary, the few things I would like you to take away from this. When moving to the cloud, or even if you were to move away from the cloud back to on-prem, change is constant, right? So there's going to be a few things that you need to address. And the main things that you would like to address in terms of, that you would like to address in a change like this is managing psychological safety. There might be people that are reluctant to change. The organization might be reluctant to change, but these things take time, and it's all about building in trust and identifying the areas in your organization where you'll see that immediate feedback and you can get some kind of trust and build up the excitement when moving to cloud is a big aspect as well, because a lot of people in organizations are really excited about making that leap into cloud, not only GCP. Again, quickly looking at my notes, it's a balancing act. All these changes that you need to make. Again, for every organization, the changes and the rate of change that you make is going to be very specific to how you work internally and the kind of customers that you serve. So have fun, embrace the change, and remember, change is constant. And I think that's a wrap from me. Do I have any other points that I would like to make? I think that is it. Yeah, thank you.
Fantastic job, Jai. Fantastic job. And you know something? I'm not even sorry that this was such a short time, because now we can use this as like a teaser for the SRE Super Secure Roadshow with Jai Campbell and Rich Rose that will be coming to an area near you very, very bloody soon. I can tell you that now. Sorry about that now, Nabil. I just wanted to squeeze that in and put this man on record saying we're going to go and do this. I mean, this is something we got to do. I've been planning it, trying to get everything lined up.
Absolutely. He agreed to it at the beginning anyway, so he signed up his life to it. So yeah, let's do it. Brilliant, Jay. Thanks, and thanks to see you again. I mean, we met a few times face to face, and now we're doing this. So next, we're going to introducing Kiki and Rob. First, when I saw the pictures coming through, I was thinking Harry Kane is joining us.
You wouldn't believe how many times I've had that in the last couple of weeks.
Exactly. Yeah. Oh, you've done brilliant through the Euros. So yeah, brilliant, absolutely.
Not quite good enough, but it's all good.
Yeah. Anyway, yeah, it's happened. It's going to happen in 2022. So yeah, nice to see you guys. Welcome to the GTG community, and we really appreciate your contribution. I know you guys, you are first timers. We thank Jay for introducing us to you guys. So I'll let Jay introduce you, because I don't know much about you, but Jay, if you can give us some startups on Kiki and Rob,
yeah,
much appreciated.
Sure. I'll give you a very quick introduction. So Kiki Lagu and Rob Ebbs, they're actually colleagues of mine. We're working on a really fascinating GCP project, both extremely talented DevOps engineers that have just started moving into GCP platform, but already showing some incredible skills already. So I'm really excited for the talk that they're going to be presenting today.
Awesome. Thank you, Jay. Rob, Kiki, hand it over to you. Stage is yours.
Yeah.
Thank you.
Start sharing. And present. All right, I think we're ready to go. So here we go.
Perfect.
Yeah.
Cool. Cheers, Kiki. So I'll kick off with a bit of an introduction. So I'm Rob Eves. I've worked at Lloyds Banking Group for almost 8 years now. I actually started as an apprentice. I wasn't hugely keen on going to university. I just wanted to kind of get involved, really, which is great. And I'm now currently working as the DevOps lead for domestic payments. So as part of this role, I've had to kind of define our DevOps processes and assist teams with little to no automation to benefit from some of the shared tooling and processes that we designed within domestic payments. We actually started very, very basic with Jenkins installed on an old Windows 7 desktop under one of our desks, which actually got restarted every single time the office cleaner needed to plug in her vacuum cleaner, which wasn't great when you come in on a Monday and Jenkins isn't working, and then you look under the desk and realize why. But that's just kind of a taste of how basic we were. But I'll go into that in a little bit more in a minute. So I've been involved in our cloud work within the bank for the past couple of years, and actually only started working on the Google Cloud platform part of that in the last 3 months or so. Before that, I had some limited experience with GCP, aside from once trying to use some of the machine learning products to predict the results of horse racing with some very, very limited success. So there's a little bit of an introduction from me, Kiki.
Yep. So I'm Kiki. I started off as a software engineer, and I'm getting into DevOps now, which is super exciting for me. It's an area that I discovered just after I graduated university. So I graduated in 2019, so I don't have many years of experience in this field. But since joining sort of my company and this project, apart from Java, obviously, I'd never used any of the tools and technologies that I've actually been very lucky to get to know and work with over the last year or so. So needless to say, yeah, there's been a huge amount of learning from my side, from everyone's side, I'm sure. And today we'll sort of be sharing with you some of our experiences and a couple of tools in particular that have really stood out to us on this sort of journey into the cloud. Yeah, so let's get into it.
Cool. Thanks, Kiki. So I'm going to kick off with a little bit of history of where we've come from within Lloyds and kind of our journey to the cloud. So fairly high level, and then I'll pass back to Kiki, who's going to go into a little bit more detail into kind of what we're doing currently and the tools we're using and our experiences of that, really. So to start off with, previously, all of our servers were housed on-premise, and it was actually a very, very manual process to kind of get anything done, really. So to get a new VM built, for example, being a bank, there's often a lot of processes which can sometimes be a little tedious and feels like it kind of stops you from doing what you really want to do. But of course, there's really good reasons for those processes being in place. I actually remember trying to get a VM to install Jenkins once. That was our upgrade from the desktop underneath my desk. That was probably around 4 years ago. And it actually took over 3 months to get a VM built and configured. So quite a long time. And they were actually built by hand by our SD team. So no two VMs were ever actually the same. So not particularly useful when you're trying to do repeatable tasks. So that was probably 4 or so years ago. And since then, as I touched on a minute ago, we've really accelerated our DevOps processes and just our general automation, doing automated testing and all of that amazing stuff. And yeah, within the last year or so, we've come kind of on leaps and bounds, and we've got a lot more automation within the bank. We now have services allowing us to spin up VMs within about half an hour, so a lot better than 3 months. Better, but still not exactly perfect. So that's kind of where we're heading now. Moving on to more recently than that, we've been exploring GCP as we just touched on, and we're making some great progress on the platform and seeing some huge benefits from doing that, which Kiki is going to tell you all about in detail in a few minutes. Just before we get into that, I just want to give my kind of personal experience of using GCP, and it's actually been a great one so far. For example, using things like Terraform to kind of reliably and quickly create resources seems a world away from the process of waiting 3 months for the equivalent of a compute engine instance to be stood up. which is just, as you can probably imagine, it's just such a huge benefit from what we were doing before. Personally, getting up to speed with GCP and the products offered has been a fairly smooth process. There's so much information available online, and the training models have been a great help. Of course, the only real way to learn, I believe, is to get fully involved and kind of into the nitty-gritty of things. So that's what I've been doing for the past few months, kind of getting involved, making some mistakes, doing things completely wrong, and then learning from that the right ways to do things, which I think whatever you do, having the confidence to go in and do that and go in and make those mistakes and be able to learn from them is 100% the best way to learn, as long as you don't do anything too drastic, of course. But of course, we've got all the guardrails and things like that in place so that people can learn with that confidence and can try things without kind of risk of absolutely breaking everything, which is great. So that's a little bit of history from me. So we've come from an on-prem setup where everything was owned by us, but things took a long time. So VMs, a very basic thing to get a VM up and ready for someone to use for testing or whatever it is, and that could take 3 months. So I think that's interesting knowing where we've come from, but what we really want to talk about is where we're heading now and what we're working on and what's to come in the future. So I'll hand over to Kiki, who's going to tell you a little bit more about what we've been up to on GCP and what we're looking at next.
Yes. So from 3 months to 3 minutes, and how we're making that 3 minutes kind of a reality with GCP. So Rob and I are working for a company in the financial services sector. So really, the move to the cloud was all about a part of a digital evolution and overall sort of cloud transformation that the organization that we're working with wanted to go through. So all this was in an effort to sort of boost efficiency and offer new and innovative services to the bank's customers, really, and to help streamline and modernize and improve all the customer experience. So GCP has been a great tool for engineers of all experience levels, in my personal opinion. And the community and documentation that you have for this particular cloud provider has been amazing. It has a very large offering and multiple options for deploying things. But today, we'll just be touching on 3 main things within GCP that we've kind of worked closely with, and then we'll dive into a couple of interesting tools. So the first one of these that I'd like to talk about is sort of Google Kubernetes Engine. So JKE clusters are powered by the Kubernetes cluster management system, and sort of Kubernetes provides all the mechanisms through which you can sort of deploy, interact with your applications, workloads, and of course commands, everything that you need to manage those and perform administrative tasks, monitor them. So it's been a really great way to embrace Kubernetes, and it's great that sort of Google has that offering. It's been utilized, it's the main thing that we use to deploy our sort of workloads, so it's exciting to work with. It also allows you a lot of optimization. So, you can, Google has a lot of great documentation on JK, and all about the auto scaling capabilities, the sort of custom resources that you can provide your clusters. It also sort of really gives you ability to have really good insight into everything that you deploy, and that's been really valuable for us as developers, as an organization. Gives you visibility into network traffic, with all the additional sort of Kubernetes metadata, which for security conscious businesses like those in financial services is super useful, obviously. So yeah, GCP has really enabled the learning of Kubernetes for me in particular, and there's been so many great opportunities to learn this through JKE in particular. And as Rob said earlier, the best way to sort of learn something is to get into it, get into the nitty-gritty and experiment with it. So the other sort of thing that I want to touch on is Google's offering of virtual private clouds. It's a global isolated virtual network. It's the virtual version of a traditional physical network, and VPCs are are global, spanning multiple regions that Google offers. And it's been really great because from a security perspective, as part of the sort of the business that we're working for, it allows you to really protect whatever you deploy and put really hardened controls around your work. So yeah, I mean, some of the cool capabilities include like identity and access management. So getting really specific on the security side of things, it's all inbuilt into Google Cloud. And sort of infrastructure and network security, like Google Cloud's Cloud Security Command Center, that gives us real-time view with no mechanism, sort of no mechanisms for historical queries, but it's really useful to sort of look into particular things on our GCP platform. So GC, so Google's compute engine and the VMs there, that we kind of base our JKA clusters on, are sort of patched by Google standards very regularly, and they're always as secure as they can be. And GCP really finally, through their VPC and sort of networking capabilities, has allowed us to really be security conscious and focus on minimizing any sort of effect that, say, a possible breach could have. And that can only be good for businesses and their customers. So it's really good tool to work with. On top of that, obviously, the monitoring and alerting capabilities are super useful, and GCP is super resilient with multiple regions, or data loss prevention, data backup, and data availability and recovery. So, which brings us on to the third point, which is data, which is really at the heart of any financial institution. In terms of its customers, all the transactions that happen. I mean, GCP really provides a lot of functionality from what we've seen to manage and make use of all that data that flows through our cloud ecosystem. So overall, GCP is allowing us to spin up the services we need in a really secure and modularized, buildable way. And we can really take advantage of like frequent iteration, frequent releases, which in the past would have perhaps not been possible. So having said that, of course, all this is really underlined and supported by two really cool technologies that I'm going to go into now. The first one being Terraform. So a little bit about our workflow first. So of course, Terraform is one of our tools that we sort of use for infrastructure setup. And after sort of infrastructure setup, we go into deploying our applications, testing and releasing them. Now, Terraform is, I'm sure many people are sort of aware of Terraform, but it's a tool that we're organizing for all our cloud deployments, deploying all our cloud infrastructure in sort of the most standardized way that we can. So a few really cool things about Terraform. Firstly, it's an incredible tool for collaboration, in my opinion. So keeping Terraform code in GitHub, from what I've experienced, first allows for transparency, and it really helps encourage knowledge sharing between all the teams that work with this sort of technology. I mean, changes and infrastructure as code sort of scripts are visible not only to engineers that are working on developing them and extending them, but also to those consuming them. So being a part of one of the teams that consumes those sort of resources in my sort of project, I found that extremely sort of enlightening in terms of learning, in terms of being a part of a wider sort of, not just my own team, but a part of the wider project and contributing to how we build our infrastructure. Of course, that also means debugging is easier because there's a constant review and there's a constant review, sort of an improvement of the modules. And as well as just being a collaborative tool, it really allows for automating deployments and configuration on our platform and reduces time needed to provision resources to, I mean, times that were not possible using tools before. So there's a lot of provisioning and automation capabilities in place today across multiple platforms. And using Terraform actually really allows us to make use of the core infrastructure that we create, provision it to be less error prone. So where it could take weeks or days to provision networks and subnets, from our personal experience, I mean, work that we're even doing like right now, Terraform enables us to do that in minutes. So, and we're utilizing templates that are quick and easy to sort of provision multiple things in parallel. So that itself can just make sort of whether it's a first-time cloud moving into the cloud or if it's a migration into the cloud, very speedy and efficient. And not only that, but Terraform is multi-cloud, so it has support for all the major cloud providers. Now, whilst we have mostly just experienced GCP on this project, let's say you need to sort of transport your infrastructure or start creating infrastructure in other cloud providers. I mean, all the major ones, really. You can utilize Terraform for that. And not only that, but you can extract infrastructure that you've already created into modules and sort of make them portable in that way as well. So it goes back and forth, and it's just a really cool feature of Terraform. And so Terraform just on top of this, it's really gives the power to us to like achieve really great scale. I mean, we grew in the project that I was in originally, that kind of transformed into the project that I'm in now. We grew from this tiny sort of platform into a huge multi-stream sort of platform. And Terraform has helped us both do that horizontally and vertically. So, and yeah, it's cloud agnostic, and it has great, on top of that, something that I have found really interesting about Terraform actually is that you can automate security checks and the use of policy as code. So things like service control policies or firewalls, compliance checks, they can be kept as code just like anything else. And it's super valuable when you have sort of multiple teams and streams within an organization who need to provision different resources, but still maintain sort of the same high level of security and quality across everything, which has been really cool. And yeah, it's not only, so finally, just as a closing thing for Terraform, it's been a really interesting tool to work with when you need flexibility. It allows you to provide one workflow and provision whatever is needed in the cloud, in whatever cloud that developers may want to provision it in. So being able to leverage whatever services a cloud provider offers without having to change your workflow is incredible for efficiency. As organizations sort of grow, as teams grow, they might want to leverage offerings from multiple cloud providers at the same time. And Terraform really allows you to do that in a standardized way. So it's not only great for initial business sort of moving into the cloud, but also like cloud migrations from one cloud to another. So that is a bit on Terraform. And the second tool that has really struck out to myself personally, I'm sure to many other people that have worked on it, is Spinnaker. So Spinnaker is a multi-cloud continuous deployment tool. It's used for building and releasing software changes into the cloud. It takes out all the manual activities by sort of automating all the processes that you need for your deployments, and supports, just like Terraform, deployments into multiple cloud providers and multi-cloud environments. So Spinnaker helps us manage our applications in multiple ways, and I'll go into that. It was open sourced by Netflix in 2016 and has been sort of worked on by Google a lot. And it was designed to combine, not just offer simple arbitrary execution tasks, but actually has a great support for cloud concepts and cloud sort of things. So when combined with something like JKE, which so Kubernetes engine in GCP that we're using, it's a really powerful tool because not only it allows you to deploy, but also it allows you to manage your infrastructure. So your pods, services, things like that. So it's a great match for Kubernetes clusters, essentially, and many other things. So because Spinnaker has all this native support, right, for Kubernetes, it's actually possible to even monitor your clusters from within Spinnaker itself. So, I mean, you can spin sort of resources up and straight away see them in the UI and see what's happening with them, whether your workload is up or down, if it's having errors or issues. And you can even manage your rollouts with it. I mean, you can roll back, roll out deployments, and it's everything in one place, and it's just a great tool. I want to say again, I've mentioned this just before, it's multi-cloud, so it's able to deploy across multiple cloud providers, all the major AWS, GCP, Azure. So if you compare it to other similar tools, which offer only limited support for cloud providers, it's a really great thing when you're moving into like any sort of cloud platform to have in your sort of organization. I mean, a lot of other tools require work on top of them to be suitable for deploying into cloud environments. So Spinnaker is actually a really great tool for that. It's also because Spinnaker itself has microservice-based architecture, so the tool itself can be scaled. So it's not just for huge organizations. It can really be flexible in that a tiny organization with minimal amount of workloads they need to deploy and manage can get the most out of Spinnaker. And it's really not an overkill to use Spinnaker as much as a huge organization with many sort of workloads to manage, because you can scale the microservices that underpin Spinnaker to suit your needs. So, and that's also obviously cost effective. And sort of what's something that's really useful about Spinnaker, and that actually mirrors what's really cool about Terraform, is it's all code, so pipeline as code. Spinnaker defines all of its pipelines as code, and sort of the whole pipeline is stored and managed as JSON. You can maintain them in GitHub and load them into Spinnaker. I mean, you can sort of a Spinnaker pipeline can be used as a master to update other Spinnaker pipelines. So it can be really synced, and it can be synced whenever there's updates to Git from Git repos, so that Spinnaker pipelines get updated automatically too. So it's got great sort of functionality there. And it has great inbuilt security again. All organizations nowadays focus on security, but especially in financial services, making sure that you have features like role-based, like access control, authorization, role-based access control. Spinnaker has so many utilities to allow you to control who sees what, who deploys what environment you can go to, and who can take workloads to those environments. And it's all based on individual users. It's sort of integrated into SAML authentication, like Google authentication, LDAP, various things. And you can manage everything through sort of different Spinnaker user groups. And yeah, so Spinnaker has been an incredible tool to work with. And yeah, overall, just a really useful thing to have when we're sort of trying to deploy fast into the cloud. And when you have multiple teams trying to sort of iterate very fast, Spinnaker has been just incredible for that. And so, just conscious of time, I think we're doing well though. What have been sort of our key takeaways from our experience moving into the cloud so far? So it's been a long journey, but I feel like utilizing all these tools, we've come a really long way really fast. So it's been incredible to see that. Some of the key takeaways that I've had is, it's really important to choose the right tools, because you really want to sort of, they really determine what experience you're going to have moving or migrating into any sort of cloud. You want your tools to be flexible, obviously, and have good community support or like everything like that. they should be extensible and secure. And I feel like the tools that I've come across in the project I'm currently working on, a couple of them that I've just talked about, really are the definitions of flexible and extensible. So it's really cool. And so the type of tooling as well that you should use, it should be, you should use it because it's repeatable and fast. So those have been some of the sort of key decision drivers behind the tools that we're using as well, I believe. And instead of focusing solely on technologies, what's been really interesting, sort of working in financial services, is how organizations make security, compliance, customer experience, all that sort of thing, all top priorities alongside the technology, because those things really add value and just, really take the technology to the next level anyway. And so, having said our key takeaways, what's sort of in the horizon for our organization? These are just some ideas. For example, utilizing AI and machine learning to really drive and enable us to have more insights about the data that flows through our ecosystem, and make sure that we're making the best use of it, and offering really unique and cool services to customers to be what they need and what they want, right? So that's an exciting possibility for the future, but maybe. Another thing is being multi-cloud. Like, again, maybe as mentioned before briefly, each cloud provider has really cool offerings. And if an organization wants to make use of a combination of those, it's totally possible. And there's so many sort of tools and technologies out there that allow you to do that, and it's another exciting possibility for the future. And finally, so I want to call out the Lloyd's open source mission, which is an initiative by Lloyd's banking group to sort of encourage the use of open source technologies and contributions to open source. Why I find that really inspiring and exciting is because a lot of the tools that we use are open sourced, and to be able to integrate ourselves into that community and contribute to them is just as working as part of a company on a product for their customers is just really an incredible opportunity, not only for learning, but sort of for creating and bringing new things out for these technologies. And that, I believe, is everything. So I think we're a couple of minutes early, but if it's all right, I'll stop sharing. Hang on.
That's no problem at all, Kiki, and congratulations, well done on your first talk.
Yeah.
Rob, of course, you did fantastic. but I think, to be honest, you were just letting Kiki take the load there, weren't you? You were just sitting back enjoying it.
A little bit, yeah.
I can understand why you do that. Kiki, you did a fantastic job. Well done. So at this point, I think we'll bring back in Jai if he's okay with that, and as soon as Rich jumps back into the stream, if he does jump back in, we'll add him too. Oh, we have Rich Rose as well. Oh, we have everybody. We have the full deck. So I did notice a theme running through all three presentations. We started off with Rich Rose mentioning that he used Terraform. Well, he didn't mention it by name during his talk, but I think we forced it out of him in the conversation afterwards to store his infrastructure as code. And again, Jai brought it back up again, how important these things are to be able for the repeatability and the testability factor. And again, Kiki, you impressed upon us how easy you found it to use as a user and a builder. Now, I did a quick bit of research while the talks were going on, and I did see that there was some Quick Labs that have both Spinnaker and Terraform in Quick Labs since they've been worked on by Google. Is this something you guys, Jai, you've probably taken all the certifications already, haven't you?
I've done quite a few. I think I've got a couple more, mainly on the AI and machine learning. That's mine. That's the next area I need to start focusing on.
Rich, did you have a hand in building out those courses?
I cannot take credit for any of those courses. They're not mine. But yeah, they're quite enjoyable. I think the interesting point about, I guess, just generally everybody now seems to be using infrastructure as code, which is a pretty awesome thing to see. It makes your life so much easier adopting that. And it makes it a bit more, to use the word of the current vocabulary, inclusive, because it is much easier when people don't need to understand various different technologies, just can see the plain text and see what things are being done. So that's always cool to see.
So there's, I think one of the next initiatives from the GDG global kind of initiatives is going to be some of the cloud hands-on labs is going to happen next. So Rich, Jai, Kiki, Rob, would you recommend if we try and took on maybe a Terraform lab? Would that come highly recommended from you guys?
Oh yeah, for sure.
Definitely. I haven't taken any of the labs, but I definitely should. I feel like I've gone ahead and I've been using Terraform, but haven't actually done any of the trainings. So
well, Kiki, we're always looking for people to help lead these cloud labs. So if you're interested and available, we'd be very happy to have you. You as well, Rob. Jai, you'll be forced into it, I'm afraid. You're SRE London.
There's
Rich,
an
we're not.
interesting link though, because Jai was mentioning earlier about Cloud Foundation Toolkit. So actually on the Quick Labs platform, there's actually, I think there's a quest, so a series of labs relating to the Cloud Foundation Toolkit.
There is.
So, and that's super good. I've done that myself, and that's really helpful because we are currently doing a project that I will not name in the background, which uses that. So yeah, that is a nice way to understand how to make your code a lot more modular in nature, but also make it extensible as well.
Kiki mentioned Spinnaker, and also that Google did some work on it. Do you guys use Spinnaker internally?
I don't. So I think most of my stuff is serverless. So I normally do either serverless or Kubernetes. For all the stuff
I would have never guessed that you use serverless.
Thank you. Most of the stuff that I use is probably a lower order of continuous integration. So I pretty much every single day use Cloud Build all the time. I automate everything in terms of Cloud Build. But then when I need to go to like the top level, because one thing Spinnaker is awesome at is it has checkpoints, so you can stage things and get people to say, yes, I approve, that should go to the next level. That is amazing, and it works seamlessly. So yeah, if you have the opportunity to use it, if there are any Jenkins heads in the crowd, then it's definitely something to explore. You can also, which is awesome, you can use Jenkins with Spinnaker. Amazing. And it's like it's adding a nice tabletop to an unfashionable table is probably the best way I put it.
Also deploys to OpenStack as well as the public cloud. Yeah. Also a very nice feature. So guys, I know you've all been kind of watching each other's talks. Do you have any questions for one another? I think this is probably the most interesting part to find out because you guys are all experts in your own right. So what do you guys think?
Shall I go first?
Yeah, go on, Rich. Why not?
So it was interesting and surprising to see the commonality across the talks. It's nice to see so many organizations adopting open source technologies, B, utilizing them correctly, and C, spreading the love in terms of the community as well. That's always awesome to see. So for Jai, a lot of the stuff that you mentioned in there. So I think, what month are we in now? July. I think my DevOps exam is way to the back end of September. So I've got what's the difficult one? The networking. I've got the networking one next. Okay. So, but a lot of the stuff that you touched on there, I did a review of a DevOps book probably 3 months ago, which has just come out, and that includes a lot of that stuff. So I'm pretty much down with the SRE. I mean, it's pretty cool.
I may have to write a book, Rich. I'll ask you for some pointers.
Rich, do you have a link to that book there, and I can put it on the stream?
No, I don't. Sorry.
Fair enough.
I'm always on to the next thing. That's what I do. So I'm always on to the next thing. But it's also I love what Lloyd's are doing. It's pretty cool, man. So all good.
So I have a question for Rob. So
this better not be about the Euros.
Where they're using Spinnaker in the training room. My question to you, Rob, is your experience in GCP and in open source. In your time so far, what's been your favorite tool and why?
My favorite tool, that's a good one. I'd probably stick with the theme. I think Terraform, in terms of what we've been using. I just think from the comment I made around where we used to have VMs kind of hand cranked by people and everything being completely mismatched, I think that's the one key thing that Terraform helps you avoid. Make sure that everything is always the same. You can roll back and make sure everything is versioned. And I find with Terraform, it's really easy to see what's going on as well. So you know exactly what to expect. You know what you're going to get at the end of it. So there's no nasty surprises. So I definitely say from the stuff I've worked on so far with moving towards GCP, that the kind of increased use of Terraform to do pretty much everything is 100% would be my number one thing so far. And there's still little bits that I haven't explored. So there might be other bits that come up as well. But I think for now, definitely Terraform.
Rob, did you go directly to Terraform? Did you try Deployment Manager first? Because that's the proprietary tool in GCP to do infrastructure as code.
Yeah, guys, you might have to help me out on this one. I didn't have any involvement using Deployment Manager, but
okay, yeah. So it makes sense because Terraform is multi-cloud. So we've seen a lot of organizations going directly to Terraform because they've got multi-cloud environments. So Terraform works beautifully with cross all platforms. So yeah.
That's a really solid point actually, because I'm currently straddling both worlds in terms of Deployment Manager and Terraform, and that's where Jai's point earlier on about Cloud Foundation Toolkit came in handy, because there's a nice correlation between the two in terms of the examples, which is nicely done. But yeah, if you work in both worlds, then it can be quite confusing.
I'm gonna throw a question straight back at Jai. So you mentioned FinOps in your presentation a little bit. What would be your number one kind of piece of advice for people on considering FinOps, and when they're taking their first footsteps into cloud? How would you say to kind of take FinOps on board?
I'd say very good question, and thank you for asking that. I'd say start early, start as early as possible, right? If you're moving into the cloud, have one billing account and attach all your projects to that one billing account and get everybody on the same page. Again, it's a massive culture shift when moving to the cloud, and especially standing up a FinOps team. So start early and start incrementally on your wins, but getting that initial visibility into what you're spending in the cloud, who's spending what, and what they're spending it on. Once you've got that kind of wide spectrum of insights, then you can start making some engineering changes.
Yeah, definitely. I think that's one of the main things I've seen from our shift to GCP. I think previously on-prem, we were paying for our data centers, we were paying it regardless. So whether you had 1 VM or 10 VMs, they're still going within that data center. You didn't fully get that visibility, so it wasn't really a consideration. So it's quite a huge mind shift to then go, okay, if I'm turning this compute engine on for 5 minutes, it's going to cost me. I can't leave that on for 5 months and accidentally forget about it. Made that mistake on my own personal account, but we haven't done that within Lloyd's yet. But so it's a huge mind shift. But yeah, definitely, I think you're right. Just considering the early days is the key thing.
Quick question to Kiki. You touched on Terraform service controls from security perspective. Are these now fully supported on Terraform for GCP or?
So
or do you send it to?
again, I'll speak on my limited experience, but what
Yeah.
we've sort of done is inbuilt compliance checks, and I believe that is a Terraform feature. I might be wrong here. I have to double check. If I am wrong, apologies. But yeah, it's you can sort of specify exact controls that you want and checks that you want all your resource, whatever resource you're creating to run against. I mean, yeah, that is the majority of what I've sort of worked on personally. So I can't comment on much else, but it'd be definitely interesting to find out, as you say, if it's sort of an inbuilt to GCP type of thing. Yeah.
Okay. Yeah, because there's always new services in GCP, so there was always you will find a gap between what is supported on the Terraform template. So sometimes you need to wait for those to be updated in order to deploy them via Terraform. So yeah, I just wondered if you deployed those. But yeah, thank you for that. Thank you.
Jai, quick question. Well, more of a statement than a question to everyone. Jai, during your talk, you mentioned the second way. It was from one of the DevOps handbooks about left to right feedback, and also psychological safety when the transition happens going to cloud, which is the fourth ideal in DevOps. Again, this is all borrowed from the Phoenix Project and the Unicorn Project, which are two famous storybooks that have a factory move into what we see now as the cloud, and deploying often and getting things rocking and rolling. They're great books. If no one's read them, listen to them, whatever. I'm assuming that everyone on this call probably knows them back to front. My question is that where would someone go next from those? Sorry, did I mute someone there?
Sorry, my connection just went a bit flaky then. So you're talking about psychological safety. Can you hear me?
Yeah, we can hear you. I just had a visitor pop into the room to tell me.
So from the psychological...
Go ahead.
So building on the psychological safety, it's all about building that internal culture. Again, every organization needs to recognize where there's going to be resistance within the organization to change, and how you can upskill and bring that kind of confidence in. It's all about understanding and communication with the wider organization, and taking it in small steps is the best thing that I could say, especially coming from SRE. When you're making these big cultural changes within an organization, people feel uncomfortable generally, and it's about getting everybody on the same page and realizing what the benefits are. And sometimes it's good to show them other organizations that have been in a similar journey, or attending a meetup where you have an engineering team from a similar organization talking about their journey, similar as we did today with Lloyd's moving into GCP, sharing your successes and your failures, and then having an open conversation about that. It's always iterative, and it's always something that you have to continually building. Similar to what Nabil was talking about, the Terraform modules, it's constantly changing. Culture, technology, it's just about being on top of that and making time so that you can build it in. Does that kind of answer?
Absolutely, Jai. Thanks very much. Really appreciate that. Yes, Jai, we heard you. Poor old Jai is stuck in connection hell.
Thanks.
I'm just typing through to Jai. Yes, we heard you. So, Rob, any advice on people looking to go down the DevOps route? Where would you go next from the kind of Phoenix Project route?
Yeah.
Anything to read? Anything to look at? Blog posts? Anything?
I mean, for me, DevOps is all about trying new things and trying ways to kind of improve your processes. So my advice wouldn't particularly be go away and read a load of stuff. It'd be find something you want to try, find something you want to improve, and go and do it. I think that's where we started within my team. Is, like I said, we kind of borrowed an old desktop, stuck it under someone's desk, and installed Jenkins on it, and that was our first foray in our whole kind of area into DevOps. So that would be my advice, really. Anytime you want to try something, don't be scared to try it. If you think Spinnaker might improve your processes, or Terraform might improve your processes, or any tool or any process, doesn't have to be a tool, give it a go, see what happens. If it doesn't work, then what's the worst that can happen? Just get rid of it. So yeah, that'd be my advice, really. Just give it a go.
Kiki,
Definitely.
any advice?
Yeah, I definitely want to sort of echo Rob's point. I think particularly I want to speak from my own personal experience. I mean, I wasn't a DevOps engineer maybe like 3 months ago. So the way I kind of got into it, yeah, I mean, as well as reading and trying to do, it was all just being thrown in the deep end with these tools. And that's the best way to learn, because, I mean, it's difficult because, of course, you want to have the theoretical background and understanding about everything, but unless you sort of fail, you're never going to know all the ways that you can fail. And I feel like once you fail a few times, you keep seeing these patterns emerging, and you see those patterns not just in one place in sort of DevOps, in a particular DevOps tool, but sort of across. And I mean, that's been my experience getting into DevOps as well. It's a field that I really wanted to break into, and experimentation is the only thing that I would say allowed that. So yeah,
it really does bring back in Jai's comments about psychological safety. Having that safety from the company, say, go and fail, go and break things.
Yeah.
We'll all learn from this. We don't all have to make the same mistakes, but just be open and honest about it. And it's okay. We're discovering here, and we're going to get better. We just got to break a few eggs to make the omelet.
Definitely, yeah. A lot of eggs.
Hey, that's what the public cloud is for, isn't it? We can spin up and spin down machines as we need them.
I think it's always a balance. It's not. I mean, you guys, you're a lot hands-on on stuff, but it's always a balance of going back and learning the best practices, and as you go along, as you do those practices, because just doing hands-on and breaking things over and over again, your journey is longer. But if you have that balance, knowing the best practices, things like the things that Google do with SRE, for example, if you know those concepts and the methods and stuff, it will make the journey a lot efficient, rather than just going, just trying again and again and find out, oh, I know why this breaks after 3 or 4 tries. But if I follow best practices, that journey is balanced between hands-on and knowing those best practices, make it a lot efficient, I think.
Definitely. And I want to add one other point. If you're sort of a software engineer looking to get into DevOps, which I feel like was my path, or just in general, if you're in DevOps, don't let go of software engineering knowledge and best practices, because all the DevOps tools that we are using, like Spinnaker is just written in Java. I mean, what I'm trying to get at is all the tools that we use within DevOps, they are sort of coded somewhere. So being able to understand how a tool is built helps you be able to use it better and debug it, all sorts of things. So I think I do think software engineering and sort of coding in general, programming, is so key to being a good DevOps engineer. Yeah, at least it's helped me a lot. Yeah.
Thanks very much, Kiki. I think we've run past our allotted time. Dr. Nabil, as our cloud lead, leading the Dev Party Cloud Track into DevFest this year, would you like to give the closing remarks?
Closing remarks. Before I do that, I would like to Rich tell us about Google Cloud Next this year. So is that going to be like he's laughing? Yes, it's going to be digital, isn't it? Again, I just want to ask about the Cloud Hero events and things like that. Are these going to still happen digitally or things like that? Or?
So for the Cloud Hero piece, will be bigger than ever. So we've got some good stuff coming there. Generally, as you might expect, the event will be digital. But we'll still have lots of good stuff running, and then an extended portfolio of labs as well, as we move into new areas. So yeah, there's lots to expect from that.
You are keeping a lot of things secrets here. You're keeping just teasers. You're giving us teasers, a lot of teasers today. So
you got to imagine in the background we're doing lots and lots of stuff. So I don't want to spoil anybody's thunder down the road by going, hey, we're doing this. But specifics of Cloud Hero, yes, we will be doing that.
Swag, nice swag with that. Is that going to be prizes and stuff?
I hope so. That personally, if you don't get swag for participating, I'm disappointed. So I hope there is swag available.
There you go.
For everyone. So yeah,
there you go. Brilliant. Thanks, Richard. Thank you. Thank you, guys. Really appreciate your contribution today. Hurricane, Kiki, Jay, all the guys. We would love to see you again in future events. Obviously, we are going to be starting to look at the DevFest, another big event later on this year. But in between, we'll be doing things like David was saying. We'll be doing labs and study jams. So we would like you to join us and contribute to those as well, and the monthly events. So yeah, thanks again for your contribution, Jay from RSID London as well. And we would love to see you again. And thank you. Thanks very much, and been great having you with us. Thanks a lot.
Okay.
Thank you.
Thanks a lot.
Cheers. Thanks for having us.
Thanks everyone. Have a nice rest of the day and see you again. Bye-bye.
Bye.
Bye.
Take care.